Welcome to the review of Computer Programming Zero. This module intends to give a recap on some of the concepts given on the previous programming class. It is not meant to cover all the topics, but to allow students that had a good grasp of what was taught to reinforce their knowledge of the class and to help get up to speed students that had difficulties with some of the terms used in class. We shall discuss the statements that make up a program. This includes header files and the main. And finally, review conditional statements through the use of if statements as well as for loops, while and do-while loops. Here we have a very basic program, no different to what you may have encountered in the previous course. This program will calculate the power of a number and print out the result on the console. Here we shall explain this program line by line. The first line reads include IOStream. Now include IOStream is a header file that tells the preprocessor to include the IOStream standard file. This specific file, IOStream, includes the declarations of the basic standard input-output library in C++. The following include CMath is also a header that allows you to use a set of functions to compute common mathematical operations. The next line, using namespace std, is added to not have to write std before anything in the std namespace, like cin or cout. After the proper header files have been included and the namespaces have been set, we proceed to our actual program. Every program has a main, and everything between the braces are considered to be the definition for the main. Inside the main, we declare three variables of type double called number, value, and result, which shall store the values that will be used in the program. Next, you see a statement that reads cout. This is used to print things in the console. In this case, it is used to tell the user to enter two values. We then use cin to receive the values entered by the user and store them inside the variables number and value. We then use pow to calculate the result of the value inside the variable number elevated to the power of the variable value, and it's stored inside the variable result. Finally, cout is used again to print the result of the operation, and then the program executes the return statement, which signifies the end of the program. Notice that all instructions ended with a semicolon. This is because it's necessary, since in C++ it signifies the end of that instruction. Here we have a program with a conditional statement. The user enters a number and then the program determines if it was positive, negative, or 0. The program receives the number and then acts according to the flowchart that you have on your right. The program verifies if the value of num is less than 0. If that is true, then it proceeds to print you entered a negative number. If false, then it proceeds to check if num is larger than 0. If true, it will print you entered a positive number. If this is false, the number has to be a 0. It then prints you entered 0. Once any of these statements are printed, the program terminates. The conditional statements follow the following structure. You use the keyword if followed by a parenthesis. Inside the parenthesis goes the condition in which, if true, this series of instructions contained inside the if statement get executed, and must be contained in a set of braces if they are more than one line. If the conditional statement if is false, you can set another condition by adding else if. And if none of the previous conditions are true, and you want to add a set of instructions to execute, use the keyword else. Here we have an example of a for loop. This program uses two for loops to print out two series of numbers, one incrementing from 1 to 6 and the other one decrementing from 6 to 0. For loops follow the following instruction. The keyword for is followed by a parenthesis. Inside the parenthesis go the conditions for the for loop to run. An integer variable used as a counter, then a condition that says up to what value the counter variable can increment till exiting the loop, and finally a method by which the counter variable will increment. Each one of these three things have to be separated by a semicolon. Followed up are a set of instructions to execute that are encased inside a set of braces if they are more than one statement, and these instructions will continue to execute till the condition of the loop is met. Let's discuss the first for loop in the program. The for loop declares variable I an integer and initializes it to 0. This variable will be used for counting the loops. Another alternative is to declare the counter outside the loop, and as long as a variable is declared and initialized before being used in the loop, the for loop will continue as long as I is less than 6. When the condition is met, the program exits the loop. I gets incremented by 1 each time the loop executes its instructions. The shortcuts plus plus and minus minus are used to either increment or decrement the value of the counter variable by 1. These shortcuts can be used right before or after the variable. The difference between I++ and ++I is that I++ executes the statement it is in and then I increments, whereas ++I first increments the value of I and then executes the statement. In this slide, we have another form of loops, incrementing from 0 to 4. Instead of doing this using for loops, this is implemented by using while loops. Now, while loops hold a similar form of structure to if statements, but behave as for loops. Next to the while keyword, there's a parenthesis with a condition inside, and the while loop will continue to loop until that condition isn't met anymore. And then, following are a set of braces with instructions inside. Similarly to the standard while loop, there is the do while loop. The difference between a while loop and a do while loop is that in the do while, the statement inside will run at least one time before seeing if the conditions meet, since the condition is verified after the loop has run for the first time. Here we have the same program twice, one using a while loop and one using a do while loop. The programs give the same result as the conditions for the loops are true since the first iteration. This can be seen in the program outputs, which are identical.